Good morning, dear students. Welcome back again with a new session of Science 1 Reflection of Light, lesson number 11. Already we have discussed about the position of images when the objects are placed at different positions. Now it is written in the short form in the form of the table which we are going to discuss it. Now for example, when the object is between the pole and the focus, then the position of the image will be behind the mirror and the nature of the image will be erect and virtual. Erect implies above the principal axis. Virtual means image is formed on the screen and size of the image will be magnified. Magnified means much bigger than the object. Similarly, when the position of the object is at the focus, the position of the image will be at infinite distance. So we'll say that the size of the image is very big, very large, and the nature of the image is inverted. Inverted means below the principal axis. Real, real means it will form on the screen. Third position, that is when the object is between focus and the center of the curvature. At that time, the position of the image will be beyond the center of curvature. The nature of the image will be inverted and real, and the size of the image will be magnified. When the position of the object is at the center of the curvature, the center of the image is also at the center of the curvature, and nature is real and inverted, and size of the image will be same as the object. Then at a very last, when the object is beyond the center of the curvature, the image will be formed between the center of the curvature and the focus, and the nature of the image is inverted and real, and the size of the image will be diminished, means smaller than the object. And when the object is placed at a very large distance, say at infinite distance, then the image formed will be exactly on the focus, and the nature of the image will be inverted and real, and the size of the image will be point image. So thus we have discussed about all types of position of the object and its image, where the position of the image will form and what will be the nature of the image. Now that was about the concave mirror. Now we'll be discussing about the position of the image with the convex mirror. Now figure 11.12 shows an object kept in front of the convex mirror Mn. You can see in the diagram Mn is there. Now incident rays AQ starting from point A and traveling parallel to the axis, and A are going towards the center of the curvature. You can see A are going toward the center of the curvature. Now as shown in the figure. Now how these get reflected from and form the image A1 B1, that can be understood from the figure. You can see here rays of light, position of the object is AB, rays of light is parallel to principal axis. After refraction it is passing through the focus. Then another rays of light passing through the center of the curvature behind the mirror, and thus it appears to us that they are intersecting at point A dash B dash, and therefore the position of the image is at A dash B dash behind the mirror. As the reflected rays are not actually across one another, the image is virtual. The nature of the image formed by the convex mirror does not depend upon the distance of the object from the mirror. The image is always virtual, smaller than the object, and situated behind the mirror. So whatever may be the position of the object, always the position of the image is virtual and smaller than the object, and it will be behind the mirror. Now convergence and divergence of light. What is actually convergence and divergence? Diverge means when the rays of light, here in order to explain convergence and divergence, here one small demonstration is being done. Consider at a demonstration named as A. Take 5 sticks from a matchbox, arrange them so that their head band come all together at a point. In this arrangement, the heads of the matchsticks are said to have converged. So that is the second image where heads of the matchstick they are coming together, so that is called as converged. Now consider B. Now arrange the sticks so that the heads uncoated ends are together. So you can see second part of that, the uncoated heads are together, and that is called as diverged. Now, concave mirror is also called as focusing mirror. This is because, as shown in the figure, the parallel rays of light get focused after reflection in this mirror. The size of the image produced in this mirrors can be larger or smaller than the object depending upon the distance of the object from the mirror. The convex mirror is also called as dispersing mirror. This is because, as shown in the figure 11.14b, the parallel incident rays get dispersed after reflection of the mirror. The size of the image produced by these mirrors is always smaller than the size of the object. Now, how to identify, without knowing how to identify whether the mirror is concave or convex? So, certain factors are given, or certain things are given about the mirror, or properties are given about the mirror, with the help of which we will come to know whether the spherical mirror is concave mirror or a convex mirror. Let's go through it. The spherical mirror, which is used for shaving, is a concave mirror. When held close to the face, it gives vertical and larger image of the face. If the same mirror is taken further away from the face, the image gets smaller and smaller. The mirror used in cars and motorcycles are convex mirror. In this mirror, the image of a face is erect and smaller, and it remains erect but becomes smaller and smaller when the mirror is taken away from the face. As a result, we can see the images of the surrounding also in the mirror. So many objects can be covered into the small mirror. Thus, we can determine the nature of the mirror by studying the images produced by them. When the light rays coming from an object enters our eyes, we can see the object because while passing through the lenses in our eyes, the rays converge. The image of the object forms on the retina of our eye. The image formed by the light rays actually converging at a point is real image. The real image can be obtained on the screen, whereas virtual is not possible to obtain it on the screen. There are other factors which will help us to determine whether the mirror is concave or convex. The image produced by a plane mirror is a virtual image. Why? Because simple thing is that rays of light actually do not intersect each other. They only appear to us that they are intersecting, and the image formed is not on the screen but inside the behind the mirror. The image produced at a point from which the reflected light rays appear to diverge. Thus image cannot be obtained on a screen as the rays do not actually meet there. When the light rays collect at a point after reflection from a spherical mirror, they are said to converge there. When we want to bring the light rays together at a point, a converging light beam is used. Doctors use such beam to converge the light on a tooth, ear, nose, etc. Equipment using solar energy are also used for converging light. When the light rays starting from a point spread out after reflection by a spherical mirror, light is said to have diverged. When we want the light rays to spread out from a source, the divergent beam is used. As for example, street lights. To street lights, light gets diverged, they get spread out everywhere. Now we'll move to the sign Cartesian. This part uses of concave and convex is omitted as per this syllabus or as per this year. Now you can see the diagram. Now, according to Cartesian sign convention, the pole of the mirror is taken as the origin, and the x-axis is the frame of the reference. The sign convention are as follows. Now, it is similar to the sign Cartesian of x-axis and y-axis, which already we have studied in Maths 1. The object is always kept on the left side of the mirror. The distance parallel to the principal axis are measured from the pole to the mirror, and this distant object is always represented by a small letter u. All the distance measured towards the right side of the pole are taken as positive. So right side of the x-axis, as per x and y axis, plane x and y axis, when you're drawing on the graph, always left side is negative and right side is positive, and y axis upper part is positive and lower part is negative. The same thing we have to follow here also in sign convention of the sign convention. Now, all resistance measured towards the right of the pole are taken to be positive, while measured towards the left are taken to be negative. The distance measured vertically upwards from the principal axis are taken to be positive, while distance measured vertically downwards from the principal axis are taken to be negative. That is representing the height of the object and the image. The focal length of the concave mirror is negative, while that of convex lens is always positive. Now, concave mirror, why it is negative? Because always image is formed in front of the mirror, which is to the left side. Whereas in case of convex, the image is formed behind the mirror, which is right side. Therefore, it is positive. Now, mirror formula. We get the correct values of the distances by using Cartesian sign convention. The object distance u is the distance of the object from the pole, while the image distance v is the distance between the image and the pole. The relationship between the object distance, image distance, and the focal length f is called as mirror formula. The mirror formula is expressed as 1 upon v plus 1 upon u equals to 1 upon f. The formula is valid for all spherical mirrors for all the position of the objects under all circumstances. Now, we have discussed about the position of the image, nature of the image, position of the object, and now we are going to discuss about the magnification, that is size. Now, how to determine whether the size of the image is big or small? For that also there is a formula. And what are the conditions and how is the formula and how to determine it, that will just go through it. Now, the magnification due to the spherical mirror is given by the ratio of the height of the image to the height of the object. The height of the image is represented by letter H2 and height of the object is represented by letter H1. This tells us how large the image is as compared to the object. So, magnification is represented by letter capital M, which is equals to, the formula is what? Height of the image, that is H2 upon height of the image object, that is called as H1. From this it can be shown that M equals to minus V upon U. Now, minus V upon U, why here negative is there? Now, since the object distance is always on the left hand side and it is above the principal axis and therefore it is negative, whereas image distance, since it is below the principal axis, which is positive. So positive and negative, and therefore the overall sign of this formula is minus V upon U. As the object is always kept above the principal axis, kept height is taken to be positive. For the virtual image, the height is positive. For real image, it is negative. As the object is kept on the left of the mirror, the distance u is always negative. Now, with the help of this information, we can solve various sums based on the magnification. We can find out the focal length also with the help of this formula. The remaining part of the here we have completed this lesson. For the next lesson, we'll start with the new video. Till then, have a great day.